So let's look at this problem where we're going to maximize an area. So you have 100 yards of fencing to enclose a rectangular region. Now, I'm going to go ahead and draw a rectangle just because I like to do that. So maybe you're a farmer or something and you want to, enclose this region. But you have 100 yards of fencing. So that means you could put a fence along here and here and here and here. That's what you would need to do to enclose that region. So we're talking about a perimeter. Now the formula for the perimeter of a rectangle is it's twice the width plus twice the length. And so you've got enough fencing for 100 yards. So your 2W plus 2L, that is going to equal 100 yards, because you want to get as much area fenced as you can. So that's true. Find the dimensions, or the width and the length, of the rectangle that maximize the enclosed area. What is the maximum area? Okay, so now we're talking about area. All right, so we talked about perimeter, we talked about the fence, we've got an equation here. We know we've only got 100 yards of fence, and that has to cover 2 widths and 2 lengths. Okay, so we've got a rectangle. But now let's think about area. How do you find the area of a rectangle? Well, it's the length times the width, right? Okay, so I'm going to have to go with either L or W. I don't know that it really matters. You could have done it X and Y, but I'm just going to go ahead and go with the W. How's that? All right, I'm going to go ahead and divide everything by 2 just to make my life easier. So 1 width plus 1 length would equal 50. And now if I'm going to do things in terms of W, then I'm going to say L is equal to 50 minus W. Okay, now I can plug that in for the L. So area is equal to 50 minus W times W. Okay. So that might have been a little fast, but if you think about it, hopefully you can follow that or rewind and watch the video some more. But that's what I get. Now, when I multiply this out, I have 50W minus W squared. Or, if I want to get like technical with the notation here, the function in terms of W is equal to negative W squared plus 50W. Okay? And we're trying to get the maximum area. We want to maximize this function. Now, that function, A is -1, right? A is -1. So we're seeing an upside down parabola, and so we will have a maximum value. Okay, and that's what we're trying to figure out then. What's the maximum area? Okay, all right, and we also know that B is 50. Okay, that allows us to find then the vertex, so at least H, and then we'll have to plug H in to find the output. Okay, so H is going to equal the opposite of B over 2A. And so I get negative 50 over 2 times -1, which is going to be 25. So H is 25. And then I'd have to plug that in and say, what's F of 25? It's going to be negative 25 squared plus 50 times 25. Okay, so calculator time. Let's see, clear. So I think this is going to be 25 squared is 625, I think. But let me check. Yeah, okay, so negative 625 plus, I don't know what 50 times 25 is. A bunch. Oops, not 125. I was thinking it was going to be 1,250, but anyway, let's just put this. Okay, so let's see. Negative 625 plus 50 times 25. I get 625. All right, that's the maximum area then. That's in square feet. I think it was in feet, right? That would be the maximum area we can fence. Oh, it wasn't feet. It was yards. Sorry. Okay, so not feet. It was yards. Square yards. Okay, so 625 square yards is the maximum area we can fence in a rectangle. Okay.